Great, there we go. Awesome. Well, let me start over. I am pleased to welcome everyone, including students, employees, and community members. My name is Erin Cunningham Ritter, and I'm representing the College of Arts and Sciences Be Well program. We are thrilled to welcome you to this Let's See You Well event titled Healthy Lifestyle Inspired Strategies for Optimal Cardiovascular Aging, featuring Dr. Matthew Rossman, Dr. Brendan Kaiser, and along with Morgan Berryman Maciel. All of these folks are representing the Department of Integrative Physiology in the College of Arts and Sciences. Before we begin the presentation, I'd like to review a few logistics to keep things moving smoothly. Please note that closed captioning is available by clicking the live transcription button in the menu bar, and we will record this presentation. I'll post it to the Be Well site so you can check it out there in a couple of days. Also, our presenters will send a follow-up email to everyone who registered with the articles they reference, information about their lab, and answers to any missed questions. Now, I'm pleased to introduce our speakers. First up, Dr. Matthew Rossman is an assistant research professor at the University of Colorado Boulder, and he obtained his bachelor's degree in biology from Dartmouth College and his master's and PhD degrees in exercise physiology from the University of Utah at the Utah Vascular Research Laboratory in the Geriatric Research Education and Clinical Center at the Salt Lake City VA. Dr. Rossman completed postdoctoral training in the Integrative Physiology of Aging Laboratory with Dr. Douglas Seals before obtaining an assistant research professor position at CU Boulder. Dr. Rossman's research focuses on identifying mechanisms of age-associated vascular dysfunction and establishing new treatments to improve vascular function in older adults. Joining Dr. Rossman today is Dr. Brendan Kaiser, a research associate in Integrative Physiology of Aging Laboratory here at CU Boulder. Dr. Kaiser completed his bachelor's degree in exercise science from the University of Delaware and his master's and PhD in human physiology from the University of Oregon, with a focus on cardiovascular, exercise, and environmental physiology. Dr. Kaiser's research focuses on novel lifestyle interventions to improve cardiovascular and cerebrovascular health and function in midlife and older adults. And finally, I'm pleased to introduce Morgan Berryman Maciel. Morgan is a senior professional research assistant in the Integrative Physiology of Aging Laboratory. She joined the lab over 5 years ago after earning a master's in exercise physiology. Initially a study coordinator for 2 clinical trials, Morgan now oversees lab onboarding and training, participant recruitment, and workflow improvement projects. Morgan will be helping out today with monitoring the chat and answering logistics-related questions. Now I am pleased to turn things over to Dr. Rossman and Kaiser for the presentation. Take it away.
Great. I'll just share.
So it does look like we're in notes preview. There we go.
Okay. Yeah, well, thank you, Erin, for the introduction, and thank you for the invitation. Today, I'm going to be joined by Brendan, and we're going to be talking about our lab's work and healthy lifestyle-inspired strategies for optimal cardiovascular aging. So we are here from the Integrative Physiology of Aging Laboratory, which is directed by Dr. Douglas Seals here at CU Boulder. And the laboratory is to conduct translational research to improve human health span. And when I say health span, I'm referring to the period of life that's free from chronic disease and disability. That's represented by this green portion in this figure. And with advancing age, the risk of disease and disability increases, and we want to kind of delay the age at which the onset of disease and disability occurs, and thereby extend health span, as represented by a larger green triangle. We primarily focus on the cardiovascular system when we're talking about interventions to improve health span, because the cardiovascular system really plays a key role in cardiovascular health, but also a number of other physiological functions. And then in addition, another important reason why we focus on the cardiovascular system is because cardiovascular diseases are the leading cause of death in the United States and much of the developed world. This figure depicts the number of deaths, and it's from the American Heart Association, and it's from 2022, and it clearly shows that cardiovascular disease is a major contributor to mortality in the United States. When I say cardiovascular disease, I'm referring to a group of affect both the heart and the blood vessels. This includes diseases that are known as atherosclerotic cardiovascular diseases. Those are traditionally associated with coronary heart disease or coronary artery disease, diseases that can lead to heart attacks and death. That process also can occur in the circulation in the brain, leading to stroke, as well as the peripheral circulation, leading to peripheral diseases such as peripheral artery diseases. Heart failure is another major cardiovascular disease, and collectively, these diseases define cardiovascular disease and are the leading causes of death in the US. Relevant to this presentation and aging, it's been documented that the risk of cardiovascular disease increases with advancing age. This figure depicts the percent of the population that has one or more cardiovascular diseases grouped by differing ages. And what the figure shows is that the vast majority, over 95% of cardiovascular diseases occur in individuals that are over 40 years of age. And the prevalence, or the percent of the population in each age group with cardiovascular diseases, increases as with advancing age. Because of this, aging is the primary non-modifiable risk factor for cardiovascular disease. And a major mechanism by which this occurs is the development of vascular dysfunction, which is the focus of a lot of our laboratory's work. And two primary manifestations of vascular dysfunction that I'll define more in detail in subsequent slides are endothelial dysfunction and an increase in arterial stiffness. Let's first start talking about arterial stiffness. And when I'm talking about arterial stiffness, I'm talking about the stiffening of the large elastic arteries. So the large elastic arteries refer to the aorta and the carotid arteries. And the aorta is the main artery that branches off from the heart, that the heart ejects blood into to travel to the rest of the systemic circulation. And the carotid arteries are the main arteries that supply blood to the brain. And with advancing age, these arteries stiffen. This figure, or this image animation, depicts the elastic nature of an artery from a young, healthy individual. And what this shows is that with each swing in pressure, with each bolus of blood that's ejected by the heart into the peripheral circulation, a nice, young, elastic artery is able to expand and recoil to kind of accommodate that bolus of blood. And this elastic nature of the artery decreases with advancing age. So in older individuals, with each ejection of blood, there's less expansion and elastic recoil. And this has a few detrimental consequences, one of which is an increase in blood pressure, namely systolic blood pressure. So when the arteries stiffen, they are no longer able to effectively buffer the pressure pulse that's ejected from the heart. And this both directly and through other indirect mechanisms, leads to an augmentation or increase in systolic blood pressure. So increasing large elastic artery stiffening is one mechanism that contributes to increased blood pressure with advancing age. Another detrimental consequence is end organ damage. So there are a number of what we refer to as high flow organs in the body. This includes the brain, the kidney, the eyes, and these organs receive a lot of blood flow and do not have much ability to kind of buffer the blood pressure that accompanies the incoming blood flow. And when the arteries stiffen and there's loss of elasticity, there's a transmission of higher pressure to these end organs. And this can lead to damage in the brain, damage in the kidneys, damage to the eyes. And as such, increased large elastic artery stiffening is associated with Alzheimer's disease and dementia, chronic kidney disease, diseases that are associated with damage to other end organs. We can assess large elastic artery stiffening in our laboratory in clinical studies using a test called carotid femoral pulse wave velocity. And this is a relatively simple to administer test where we basically feel for the pulse in the carotid artery, so right at the neck, and then the carotid or the femoral artery at the top of the leg. And we can measure the time between when the heart contracts and when we feel the pulse in that arterial site. And from those measurements, we can calculate a speed. And the faster the pulse travels, the faster, that's termed faster pulse wave velocity, that's associated with a stiffer artery. So greater aortic stiffness is measured or shown by faster pulse wave velocity. The other important manifestation of endothelial or vascular dysfunction that we study is endothelial dysfunction. And the endothelium, this is an image of a blood vessel. So the endothelium is the innermost surface of the blood vessel. So it's a single cell layer, and endothelial cells interface with the blood. They're the cells that are, as they're on the innermost surface, they come in direct contact with blood flowing through arteries. These cells play a very important role in regulating overall arterial health. This includes by producing various molecules that regulate their size or their diameter. One of which very important molecule is a molecule called nitric oxide. And it's not important to know the details of this molecule. It's associated with a healthy endothelium. It causes vasodilation, but declines in nitric oxide are associated with impaired endothelial function and risk of clinical cardiovascular diseases such as atherosclerosis, coronary artery disease, stroke, and also risk factors for cardiovascular disease such as hypertension or high blood pressure. We can also have another clinical test where we can measure endothelial dysfunction or measure the presence of endothelial dysfunction, and we do this by measuring endothelium-dependent dilation. And this is a test in which the blood vessel dilates in response to a physiological stimulus. So in response to an increase in blood flow through arteries, this stimulates endothelium-dependent dilation. In young individuals, there's a large and robust increase in artery size. That's a large endothelium-dependent dilation due to a high level of nitric oxide. With aging, this response is reduced and consistent with reduced endothelium-dependent dilation and reduced nitric oxide production. We measure this in the laboratory with an ultrasound. So we do a test called brachial artery flow-mediated dilation. And this is a non-invasive assessment that we can perform in clinical research participants in which we assess endothelium-dependent dilation and basically assess the artery's ability to dilate or widen in response to increasing blood flow. So we know that with aging, vascular dysfunction develops, but what are the mechanisms? And there are a variety of mechanisms, but two important mechanisms that are kind of central to the overall vascular aging process are processes termed oxidative stress and inflammation. And oxidative stress, when I say that, I'm referring to a state of excess reactive oxygen species production or free radical production that can lead to impairments in vascular function, and inflammation, or an increase in chronic low-grade inflammation. So this is distinct from inflammation in response to an infection. It's just a state of heightened chronic circulating inflammatory factors. Oxidative stress and inflammation promote large elastic artery stiffening because they interact with the structural proteins in the arterial wall. So two key structural proteins are elastin and collagen, and these confer stiffness properties to the vessel. In young, healthy individuals, there's a balance between elastin and collagen to maintain vessel structure with elasticity. With aging and the increase in the oxidative stress and inflammation, there's a overall reduction in elastin breakdown, leading to a less elastic vessel, and an increase in collagen, promoting increased stiffness. Oxidative stress and inflammation also contribute to endothelial dysfunction. And this is primarily because these reactive oxygen species or various oxidants that comprise oxidative stress react with nitric oxide and decrease the amount or bioavailability of nitric oxide, which leads to impaired endothelium-dependent dilation. And I'm going to switch out.
So Matt has told us quite a bit about the age-associated changes in vascular function that lead to vascular dysfunction, but it's important to talk about what healthy vascular aging in a Western community dwelling cohort looks like before we set up some of those lifestyle-inspired strategies to promote that healthy vascular aging. This figure comes from a study that was a subset of the Framingham Heart Study, which is a multi-generational study taking place in the United States investigating age-associated changes that may lead to disease and disability, of which cardiovascular disease is a very relevant subset. So to orient you to this figure, what we're looking at is the incidence of cardiovascular disease events during a follow-up period of 15 years in adults that have healthy vascular aging as well as no healthy vascular aging. So the green line is individuals that do not present with age-associated increases in systolic blood pressure or large elastic artery stiffness. And the red line is individuals that display the more typical pattern, which is increased systolic blood pressure and increased stiffness of the aorta and the carotid arteries. And the key takeaway here is that individuals with healthy vascular aging have a significantly lower incidence of cardiovascular disease events during the follow-up period. Unfortunately, the prevalence of healthy vascular aging declines significantly with increasing lifespan. So the greatest percentage is going to be adults between the ages of 50 to 59 years old. And then as we increase in decade from there, it's going to be much, much lower to the point that individuals over the age of 70 years old, around 1% in this cohort presented with healthy vascular aging. This has important implications for a number of disease states that we've already discussed related to cardiovascular disease, wherein age-related increases in vascular dysfunction have impacts for hypertension, coronary artery disease, as well as stroke. But there is more broad biomedical impact for things like kidney disease, cognitive impairment, Alzheimer's disease, and related dementias, as well as metabolic disorders, fall risk, and exercise intolerance. That begs the question, what can we do? So we've established that aging leads to vascular dysfunction, but our laboratory and others have identified some promising therapeutic targets that can lead to healthier vascular aging. Our research group has had applications related to healthy lifestyle-based approaches for successful vascular aging. We're going to talk about some of those in a bit more detail, but just to conceptualize the idea, this figure does a great job of showing what the difference between primary prevention and secondary prevention is for those healthy lifestyle or pharmacological strategies. When we say primary prevention, what we're referring to is intervening before vascular dysfunction manifests, whereas secondary prevention would be implementing healthy lifestyle or pharmacological strategies after vascular dysfunction has begun to present, but before that has led to those disease states that we discussed in more detail. So all the things on the right-hand portion of this screen. What those healthy lifestyle interventions may look like include things like increasing physical activity, limiting daily food intake, as well as improving daily food composition. The first thing we're going to discuss in more detail is physical activity or exercise for improving cardiovascular health throughout the lifespan and potentially using it to improve health span. The laboratory director, Dr. Douglas Seals, has presented a number of times on the anti-aging effects of aerobic exercise on systemic arteries. So using regular physical activity as a means to improve conduit artery health and impact those two mechanisms of vascular dysfunction that Matt discussed earlier, endothelial dysfunction and arterial stiffness. With aging, there's traditionally an increase in arterial stiffness and endothelial dysfunction, which lead to dysfunction of the arteries, increases in systolic blood pressure and cardiac dysfunction. However, aerobic exercise training interventions have been shown to ameliorate a number of these age-related dysfunctions. Exercise continues to be the #1 recommendation for midlife and older adults who want to improve their cardiovascular health. According to the physical activity guidelines for Americans from the Centers for Disease Control and Prevention, adults are recommended to get at least 150 minutes of moderate intensity aerobic activity every week, in combination with at least 2 muscle strengthening activities per week. It doesn't need to be 150 minutes of moderate activity. If people prefer 75 minutes of vigorous intensity activities such as running, would also be sufficient to meet those guideline recommendations. This figure does a nice job of showing the relationship between increasing levels of what's called leisure time physical activity and the risk for mortality. So on the x-axis of this figure, we have leisure time physical activity in met hours per week. Met hours per week just refers to the metabolic equivalent of the activity that's being performed. So I'm going to talk about what this figure means in the context of those guidelines for physical activity for Americans. On the y-axis, we have the hazard ratio for mortality. So it starts at a reference level of 1, which would be the risk for mortality in people that do not exercise at all. You notice from this curve different portions. The first is going to be that there's a steep early slope, which means that there's going to be a very large benefit to just exercising any level above 0. So going from no exercise at all to even just a small amount of exercise carries benefits for reducing the risk for mortality. About 70% of that benefit is going to be reached by 8.25 met hours per week, which is going to be a little bit over where the guidelines are for exercise in American adults. This continues to taper out as this relationship continues, where as leisure time physical activity increases, there are further reductions in the risk for mortality. So exercise is clearly a very potent and effective intervention for reducing the risk for cardiovascular disease as well as all-cause mortality. But we can also talk about food as medicine. So a number of different areas within things such as daily food intake or diet composition may carry benefits for promoting healthy vascular aging. The first we're going to discuss is daily food intake. What this means is the daily caloric amount that people are consuming. So we'll talk about through the lens of 2 different publications from our research group. Individuals that are overweight and obese present with increased systolic blood pressure and impaired vascular function. So this study sought to see how 12 weeks with a 33% caloric deficit could potentially impact these 2 factors which are associated with vascular aging. And what the authors found is that there was a decrease in systolic blood pressure and a 30% improvement in vascular function after 12 weeks with a 33% caloric reduction. This was associated with a 10% reduction in body weight as well. Beyond changes in daily food intake, we could also talk about changes in dietary composition, so what it is that we are eating on a day-to-day basis. The ideas that I'm going to discuss here are covered well in this review for our nutrition and other lifestyle influences on arterial aging for members of our research group. What this figure describes is a number of different diets or factors that people may have heard of, as well as the vascular effects of these diets. What this evidence column on the very right-hand side of this figure indicates is where the papers that have been published around this diet or factor are concentrated. So with an increased number of symbols for people on the right-hand column here, that means that there is a large wealth of evidence to suggest that this diet may be effective at promoting healthy vascular aging. The animation of the animal here suggests that there's data for both human and preclinical models related to the diet and its impact on vascular effects. So each of these have a number of different dietary components. We're not going to focus on individual components because that's beyond the scope of this discussion, but we will focus on one individual element that may be common to a number of different diets, which is dietary sodium restriction. So before we get into some of the data from our research group, I just want to emphasize that the previous figure talked about broad, healthy diet patterns, and we're not going to be discussing specific foods within those healthy dietary patterns. So it's not that eating one food is going to promote vascular aging by itself, but limiting some bioactive ingredients such as dietary sodium within those diets may have benefits for vascular health. As I mentioned, dietary sodium is one such thing that we could target for improving dietary health or improving vascular health from a dietary perspective. So current recommendations for dietary sodium intake are 2,300 milligrams per day. That's limited to 1,500 milligrams per day for individuals with high blood pressure. However, the mean daily intake for US adults is 3,400 milligrams per day, so quite a bit over what the recommendations are. Limiting dietary sodium intake in older adults to just below what the threshold is for current recommendations for Americans was associated with a 15 millimeter of mercury reduction in systolic blood pressure, as well as quite a substantial improvement in vascular function. So even small changes such as limiting the amount of dietary salt can carry outsized benefits for things like blood pressure, as well as arterial stiffness, both of which are associated with healthy vascular aging. I'm going to turn it back over to Matt to talk about some alternative or complementary approaches.
Yeah. Okay. Yeah. So we, in general, our laboratory and probably the field in overall consider the healthy lifestyle-based approaches that Brendan described as the first line approach or the most evidence-based approaches for improving vascular aging in general and cardiovascular health as well. However, these approaches are associated with a number of barriers to their adoption, and this is supported by data looking at how often individuals meet the guidelines for the recommended approach. So taking exercise as an example, fewer than 20% of older adults or adults over 60 years of age meet the guideline recommended levels for both aerobic and muscle strengthening activities. As such, there is a biomedical need to establish alternative or complementary approaches that may recapitulate, at least in part, some of the benefits associated with the healthy lifestyle-based approaches. And one way to accomplish this goal is to look at pharmacological interventions. And our laboratory is active in this area of looking at these interventions. We primarily look at a class of compounds termed nutraceuticals. And nutraceuticals are food or food supplements with naturally occurring ingredients that may have health benefits. It encompasses both dietary supplements and certain functional, what are called functional foods or foods associated with health benefits. Importantly, there's a lot to consider when we discuss dietary supplements in particular, and nutraceuticals in general, because in general, these compounds are not regulated by the FDA. So the Food and Drug Administration typically approves drugs for certain clinical indications, and those, once their drugs are approved for that clinical indication, they're allowed to be marketed and allowed to be prescribed to treat that clinical condition. Supplements, they're not subject to the same degree of regulation. So supplements can claim a lot more health benefits that aren't necessarily validated from the FDA. And because of this, there's a lot of articles and confusion about different supplements. This ranges from criticism from the healthcare community that taking a lot of multivitamins or supplements may actually be harmful, or they may just be needless, to just people really being inundated with information, and physicians or healthcare providers asking their patients to not take so many supplements. So because of this, our laboratory feels it's important to establish an evidence base for select nutraceuticals or dietary supplements such that these may be incorporated into interventions to improve vascular aging. And we do this through a multi-step process. So we first identify an intervention and a therapeutic target. We then typically conduct a preclinical study in mice. And the goal of this trial is to really obtain unique mechanistic insight that the intervention we're studying can indeed target whatever we're trying to target. So it can reduce oxidative stress, or it can reduce the factor we think is contributing to vascular dysfunction with advancing age. If we confirm this with mechanistic studies in mice, we then do what's termed a pilot trial in middle-aged and older adults. And this is usually a small scale, less than 20-person randomized clinical trial. So people come to our Clinical Translational Research Center on our CU Boulder campus and undergo an intervention where we measure vascular function before intervention. If we observe initial evidence of efficacy, we can't really take that as definitive evidence that the intervention does indeed improve vascular function. So we typically conduct a larger, what's termed a phase 2 or more definitive efficacy trial, where we seek to replicate and extend the results from the pilot trial and obtain evidence to suggest that we can be more confident in any observed effects that the intervention may be improving vascular function. If we continue to observe efficacy and the side effects are low and the risk-benefit ratio is appropriate, we then seek to move towards a larger multi-center clinical trial where the results from our trial are not only observed at CU Boulder in a population residing in Colorado, but also across the US. And most of our trials are kind of in this, our current trials that we're involved with are involved in the pilot trial or larger clinical trial range. A few are potentially moving towards the multi-center clinical trial realm. And then I mentioned that we target certain mechanisms of aging. And I already talked about oxidative stress and inflammation as key factors that contribute to age-related vascular dysfunction. I added a few other here that are kind of appearing in the popular press, but two other cellular mechanisms of vascular aging are a process termed cellular senescence and mitochondrial dysfunction. And we think these are, because they are cellular mechanisms of vascular aging, they're also important therapeutic targets. And we think this because some of the beneficial effects of healthy lifestyle practices, such as aerobic exercise or dietary changes, are mediated in part through suppression of these processes. And so we've done a fair amount of work in this area using various natural compounds to target these mechanisms. These include dietary interventions such as drinking daily consumption of nitrate-rich beetroot juice, which is a source of nitric oxide. We target mitochondrial dysfunction, inflammation with natural products such as curcumin, cellular senescence with compound, a natural flavonoid compound called fisetin. And overall, the goal of this research is to target these basic mechanisms of aging with natural compounds so we can identify alternative or complementary strategies that may induce some of the beneficial effects that we see with aerobic exercise and other healthy lifestyle practices. Okay, switching.
So we've talked quite a bit about the benefits of lifestyle-inspired behavioral strategies like aerobic exercise and dietary interventions, but our research group and others know that it's important to have alternative therapeutic modalities for improving vascular health in midlife and older adults. Two of the things that our laboratory is interested in are high-intensity inspiratory muscle strength training and passive heat therapy for their promising ability to improve blood pressure and vascular health in midlife and older adults with and without established cardiovascular disease. So I'm going to talk a little bit about both of these interventions now because we're quite excited about the promise they may have for promoting healthy vascular aging. The first is inspiratory muscle strength training. So although aerobic exercise is the primary recommendation for midlife and older adults for improving overall health, specifically cardiovascular health, time continues to be one of the biggest barriers for why people don't meet the recommended exercise guidelines. So the study that we are conducting and that we're interested in is using inspiratory muscle strength training, which is higher resistance but shorter duration, to obtain the same benefits of traditional exercise training. So if we think back to those recommendations of 150 minutes per week, that turns out to be about 30 minutes per day, 5 days out of the week to achieve the exercise recommendations. What we can do with inspiratory muscle strength training is use a resistive device such as the ones pictured on the left-hand portion of this screen to increase the resistance during the inspiratory or breathing in part of the respiratory cycle for 30 total breaths. Now, this works out to be about 5 minutes per day. So it's quite a big time saver compared to that 30 minutes per day required to meet the exercise guidelines using traditional exercise modalities. As you can see at the bottom, what this looks like is a much, much higher inspiratory pressure generated to breathe in against that resistive device. Another intervention that we are interested in is heat therapy, specifically the use of a hot tub to promote healthy vasculature. So some of these publications refer to different forms of heat therapy, specifically sauna bathing. So a number of studies have come out of Eastern Finland where sauna bathing is very common and part of the culture. And these publications have found that sauna bathing 4 to 7 times per week, which was the greatest number of incidences in this population, was associated with a 48% reduction in the risk for all-cause mortality and cardiovascular disease. It was also associated with a reduction in incident hypertension, which means hypertension developed during the follow-up period when these data was being collected, as well as sauna bathing is inversely associated with dementia and Alzheimer's disease in middle-aged Finnish men. So sauna bathing, again, 4 to 7 times per week is associated with a 65% reduction in the risk for Alzheimer's disease and related dementia, at least in this population. Sauna bathing, although very common in Finland and other parts of the Scandinavian countries and Nordic countries, is not as common in the US, and it's also difficult to do experimentally in a controlled laboratory setting. So our research group and others have used hot water immersion as our primary form of heat therapy to elicit improvements in blood pressure and vascular function. Some of the publications from our research group and others have found that passive heat therapy improves endothelial function, arterial stiffness, and blood pressure in sedentary young healthy adults, and that passive heat therapy can lower systolic blood pressure and improve endothelial function in healthy older adults. So what this looks like in practice is individuals would sit immersed to the level of the clavicle or the collarbone in 104-degree Fahrenheit water, so a little bit warmer than what you would find at your rec center home, 3 to 5 times per week for 8 to 10 weeks. And we're comparing this against thermoneutral water immersion, so 36 degrees Celsius, or about the mean body temperature. So it feels kind of a little bit like a warm bath that might be a little bit cooler. And it can be done in a laboratory setting. It could also be done at home. So a lot of promise for passive heat therapy as potentially an alternative therapeutic modality for improving cardiovascular health in individuals who are either unwilling or unable to engage in traditional exercise training.
Hey, Brendan, quick question. Somebody in the chat asked about the duration of the sauna sessions, and then could you also expand on the duration of the hot tub sessions that we're currently doing?
Yeah, so these top two papers that saw 48% reduction in risk for cardiovascular and all-cause mortality and then incident hypertension, the duration was grouped according to 0 to 10 minutes, 10 to 19 minutes, and then greater than 19 minutes. I'd say where it gets a little bit tricky is that greater than 19 minutes doesn't necessarily mean 19 minutes all at once. So what often is used in the sauna modality is maybe 3 groups of 10 minutes. So it totals 30 minutes, but it's not 30 minutes consecutively, compared to what is being done in the hot water immersion study, which is 60 minutes of immersion. And in fact, this initial study that was done in sedentary but otherwise young and healthy adults was 90 minutes of immersion. So the goal with hot water immersion is to increase and maintain core temperature. And it's pretty effective, but it does end up being quite a bit longer than sitting in a sauna. So it ended up being right around the 60-minute mark. Although some other studies from different research groups have found that, durations in the 30 and 45-minute range may be effective, although they may not be as effective as the longer duration. And I'm going to turn it back over to Matt to just recap everything that we discussed today before we get into some questions.
All right. So in summary, we've presented the overall picture that aging is associated with cardiovascular dysfunction, and that's a major contributor to increased risk for mortality. And the overall goal of our laboratory is to slow, delay, minimize, or prevent some of the adverse changes that occur in the cardiovascular system with aging, primarily interventions that improve vascular endothelial dysfunction and decrease large elastic artery stiffness. The ultimate goal of this is to decrease the burden of cardiovascular diseases, as well as improve function, reduce disease and disability with advancing age to improve and increase health span. Overall, physical activity and a healthy diet or healthy dietary patterns should most likely be considered the frontline, most evidence-based strategies for healthy vascular aging, healthy cardiovascular function with advancing age. But our laboratory continues to both provide an evidence base for these interventions, healthy lifestyle interventions, as well as try to identify new interventions that may recapitulate, at least in part, some of the beneficial effects of regular aerobic exercise and select dietary patterns. These include healthy lifestyle mimicking compounds, as we talked about with nutraceuticals, and also healthy lifestyle inspired strategies such as inspiratory muscle strength training and heat therapy and other strategies that we're currently exploring. So if you'd like to learn more or get involved, you can reach out to us. This is a contact us slide, so feel free to email or use the QR code to get in touch with us, and we can take any other questions that may come up. But thank you very much for your time.
Well, thank you both so much for this presentation. I would like to turn to the chat. There's a few questions, but for the rest of you who may have questions, feel free to put them in the chat, or you're welcome to raise your hand, your virtual hand, and I'll call on you. And if you're not comfortable posting a question in the chat, you can always private message me as well. So the first question is there a recommendation for heart rate while exercising based on existing heart disease and age?
I think so one thing is we are not like healthcare practitioners. We are not really qualified to give medical advice or really specific exercise recommendations. I think meeting the guidelines for moderate intensity exercise is like a 60% of 60% of age predicted maximal heart rate. So it's a moderate increase in heart rate, but that likely differs depending on pre-existing conditions. So for certain individuals with existing heart disease and other clinical conditions, that likely changes. So it is important to kind of consult your physician before adopting any new exercise program if you're concerned about adverse effects.
All right, thank you. We have another question. What about non-leisure physical activity? For example, a physical job. Are there the same benefits conferred?
I can maybe start that one a little bit. I think there is a lot of interest in what's the minimal effective dose of physical activity that might confer cardiovascular benefits. And there's emerging literature that suggests that any type of physical activity is beneficial. So job-related physical activity likely confers a lot of the same benefits. There have been epidemiological studies that look at what's termed kind of these exercise snacks or short, non-structured bursts of physical activity that might be accomplished by like running to catch a bus or walking from the parking lot, those types of things. And if you quantify those and add them up, those are the overall amount of time has been associated with reduced risk of cardiovascular disease and other diseases. So likely it doesn't have to be structured. Any amount of physical activity is likely beneficial.
Thank you. Just reviewing really quickly, you answered the questions about the duration of the sauna and time in water. A new question popped up. Any data supporting cold plunges?
I can chat a little bit about this. I would say that the data surrounding cold plunges is, I'd say, in its infancy compared to passive heat therapy for improving cardiovascular health. There's not a lot out there in terms of how it impacts cardiovascular health. Most of the data that's been collected so far has been centered around exercise performance and specifically subsequent bouts of exercise performance. So using cold plunges after one bout of exercise to promote recovery for a subsequent bout of exercise. So we don't know a lot about how the use of cold plunges in combination with things like heat therapy can promote vascular health compared to either cold on its own or hot on its own. So I'd say there's still a lot for us to learn in that area.
Wonderful. So while we wait for more questions to come in or hands to be raised, I will point you both to the love that you're getting in the chat. Our community is really appreciating the research that you're doing and how you're translating it into healthy behaviors to help support the health span. So we do have a couple more minutes. If anything else is coming up, we can pause. Feel free to pop your questions in the chat. You can private message me if you'd prefer, or you're welcome to raise your hand. So we'll just pause for a moment. Well, it looks like nothing's coming up, so I want to just quickly chat about some follow-up. Morgan has agreed to send a follow-up email to everyone who registered and attended today with the articles that were referenced in this presentation, information about the lab, and then certainly kind of points of contact if you have additional questions. In an effort to wrap up, I would like to thank all the participants for joining us today, and particularly Morgan, Dr. Rossman, Dr. Kaiser, for your wonderful work and for sharing this with our community. We're really thrilled to have you. So a big bow of gratitude from us at Be Well in the College of Arts and Sciences. And I will point you to the chat. A lot of people sending love your way and some, what are those emojis coming your way? So very grateful. And we hope to have you back soon.
Yeah, thank you very much for the opportunity to talk. And yeah, let us know if you have questions.
All righty.
Thanks
Well, with
again,
that being
Erin.
said, we will sign off for now. Be on the lookout for our November Let's See You Well. We'll be welcoming Diane Hirschhorn for another installment of financial wellness. So be on the lookout. I'll be sending more information for that workshop in a couple of weeks here. All right, everybody. Thanks so much. See you at the next one.
Thank you.